Hello, hello. Am I audible? Hello. Can anyone confirm in the chat if I am audible?
Yes.
Okay, thank you. And is my screen visible?
Yes, you are visible.
Okay, thank you.
Yes, sir.
Good evening, everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session we will discuss some practice problems for the first week's content of the course Introduction to Machine Learning. We will solve some MCQ problems and some numerical problems as well, and I will also try to answer your questions and doubts. If you have any questions or doubts, you can ask me regarding first week's content. Someone asked in the chat where we will find the recording of these classes. So these recordings, we are recording all the sessions, so you will receive the links for those recorded sessions from NPTEL. So they would give you some the sheet or something where those links for every sessions would be there, and we would also upload those sessions in YouTube. So the NPTEL will share those YouTube links with all of you. So we can start solving some problems now. People are still joining, so that would create some interruptions. So these are the logistics of my live sessions. So I will conduct live sessions every Tuesday from 6 p.m. to 8 p.m. and this is the link to join this live sessions. And this live session is of duration 2 hours. So but Google Meet doesn't allow meetings over 1 hour. So after the first hour at around 7 p.m. I will share another Google Meet link, and you have to join that meeting for the second hour of the session, that is from 7 to 8 p.m. because Google Meet doesn't allow meetings beyond 1 hour. So for that we have to take this measure. So this is the first question. Which of the following are supervised learning problems? Multiple answers may be correct. There are four options. The first option is learning to drive using a reward signal. Second option is predicting disease from blood samples. Option C is grouping students in the same class based on similar features, and option D is face recognition to unlock your phone. So which of these following are supervised learning problems? So multiple answers may be correct, multiple options may be correct here. So I have already received some answers in the chat. So Manakavu Ganeshwar has written B and D. Jamie Joyce has written B. Soham Chakravarti B. Vivek Kumar B. Many of you have already written B. And Shanti Bhattacharya has written B and D. Raj has written B. Pratik has written D. So some of you are saying that it's only B, some of you are saying it's only B, some of you saying that B and D. Anyone else? Any other answers in the chat? Does anyone think any option other than B and D would be correct? Shoham Chakravarti has written A, which is learning to drive using reward signal. Okay. Shunil has written C also. Okay, I've got almost all the options as answers in the chat already. So the correct answers, correct options are B and D here. So B and D, these are the two correct options here. So you have to find out the options which are supervised learning problems. So first option, which is learning to drive using a reward signal. So this is what we do in reinforcement learning. If you have gone through the initial introductory videos for machine learning, this is what we do in reinforcement learning, that we try to teach an agent using reward signal. So option A is not a supervised learning problem. Option B is predicting disease from blood sample. So this is a supervised learning problem, that you need to have the class levels as well to train the model to predict diseases from the blood sample. So class levels are required for option B. So this is a supervised learning problem. Option C is grouping. So grouping students in the same class based on similar features. So any kind of grouping based on some features is generally unsupervised learning problem. So this is also an unsupervised learning problem. And option D, which is face recognition to unlock your phone. So for this task also you will need the class levels. So whenever class levels are given or class levels are required to train the machine learning model, that task is supervised learning problem. So for option D also you need class levels of the faces, whether it's your face or not. So yes or no, these class levels are required. So option D is also correct, and option B is correct because you need the class levels which are the diseases would be the class levels in that case. So that's why B and D, these are the two correct options. So is there any confusion in this question? Any doubt?
Hello, sir.
Yes?
For face recognition in phone, are we really using machine learning model?
I mean, it can be done using machine learning models. Like you take several images of your face, and you have a database where the class levels are either it's your face or not. So yes or no, this class levels would be present, and based on those training data points you train the agent. So for face recognition it can be done using supervised learning. Whether modern smartphones use that or not, that is a different question. I'm also not aware whether they actually use or not.
Primarily, if you just take the image and just take a hash of the image,
Yeah,
that should be sufficient, right?
yeah, that yeah, I mean it can also be I mean it can happen that using the face and some features you extract from the face, and based on that you predict whether it's your face or not. So that can be done, but this can also be constructed as a supervised learning problem, because you have the class levels yes or no. So it can be constructed as a supervised learning problem. Our Vidyadharan has said in the chat, if we have labeled class, then it belongs to the supervised learning. Is it correct? Yeah, so if the class labels are present and your task is to predict those class levels, then that task is supervised learning. And if the class levels are not present and you have to predict clusters or groups, then that is an unsupervised learning problem. So we can move on to the second question. People are still joining. Okay, so moving on to question 2. Which of the following are classification problems? Again, multiple options may be correct. There are 4 options. Predict the price of a house, predict the disease of a person, predict the temperature for tomorrow, learn to play guitar. So these are the 4 options, and we have to find out the problems which are classification problems. So by classification problems, I mean you have to classify, you have to predict specific classes. Multiple options may be correct here. So you have to predict specific classes, specific discrete classes, and there is a difference between classification problems and regression problems. So you have to be aware of that to answer this question. So some of you have written A and B. Shandeep has written B, Sunil has written A and B, Vidyadharan has written B and D, Bharadwaj Nikam has written all 4. Okay. Soham Chakravarti has written B, Asra Khanam has written B and D. Okay. Again, Raju has written all 4 options. Sankalp Sawant has written A, B, C. Pratijit Vishwas has written B only. Okay, so I've got almost all the options in the chat, but many of you are saying it's B. So B is the most popular option in the chat, I can see. Nikhil has written C, D. Sridhar has written all. Shandeepa Vishwas has written B. Because I'm still getting answers in the chat. A, B, C, some of you have written. Okay, so the correct answer here is B, which is predict the disease of a patient. So as I have already told that you have to know the difference between classification and regression. So in classification, class levels are discrete classes. I mean the target variable or the decision variable is a discrete is a set of discrete classes. So here you have to predict the diseases. So that is a discrete set of classes that you have 2 or 3 classes that you have to predict. And in regression problems, you have to the target variable is continuous. So that is not a discrete target variable. So for example, this price of a house. So this price is a continuous value. So this is a regression problem. So regression methods are required for this. You cannot apply classification methods on such a problem. Similarly, temperature is a continuous variable. So the target variable here is continuous that you are trying to predict. So in that case, it is not a classification problem. So classification problem where the target variable is a set of discrete classes. So and disease, you are predicting disease in option B. So you have a set of known diseases, and that is a set of classes, discrete classes. So for that, option B would be the correct answer. And option D, which is learn to play guitar, so this is kind of trial and error, so this is reinforcement learning problem, so this is not even a classification or a regression problem. So option B is the correct answer. Option A and C, these two options are regression problems. You are predicting continuous target variable, and in option B you are predicting discrete classes. So option B is the only classification problem out of these four. Is there any doubt or question in this? Can the number of discrete classes be infinite in number? So generally no. I mean the number of classes should be finite, otherwise your model would not be able to predict it properly. If you have infinite number of classes, you need infinite number of training data points, so that is also not very feasible. So the number of classes should be finite. Could you please explain question once? Option A. Question 1, option A. In question 1, option A was learning to drive using a reward signal. So learning something by receiving reward signals from the environment is a reinforcement learning task. That is not supervised or even unsupervised learning. That is a reinforcement learning task. So that is very similar to this learn to play guitar. That is also a reinforcement learning task where you interact with the environment and receive reward signals, and based on that you learn. So that is also a reinforcement learning task. So we can move to question 3. Which of the following is not a categorical feature? Multiple options may be correct. So which of these following is not a categorical feature? So by categorical feature I mean there are specific number of categories present, and you are predicting one of those categories, but you have to find out which of these are not categorical features. So there are 4 options: area of a house, height of a person, types of mountains, nationality of a person. So I have already received many answers in the chat. Yeah, almost all of you have said A and B. So we have said A and B. Some of you were saying only A, which is area of a house. So most of you are saying A and B, which are area of a house and height of a person. Okay. Does anyone think any C or D should be right? Is there anyone who thinks C or D will be right, or most of you are thinking A and B? Sharandeepa Biswas has written AC. A is area of a house, C is types of mountains. Durga Prasad has written B. Anushka Vasak has written A and B. Okay, so most of you have written A and B only for this question. So the correct answers are A and B. So in categorical features you have specific number of categories. So for example, types of mountains. So in types of mountains you have specific types of mountains. So this feature would be a categorical feature. Similarly, nationality of a person, you have specific types of nationalities. So that is also a specific number of nationalities. So that is also a categorical feature. But in case of options A and B, area of a house and height of a person. So area of a house is a continuous feature. So it's a continuous variable. Obviously, you cannot group it into several types. A specific number of types, you cannot do that. Heights of a person, height is also a continuous feature. There are no specific categories in that feature. So Option B is also not a categorical feature. So A and B, these are the two correct options, and C and D are continuous features, so they cannot be categorical. So now we can move on to question 4. Which of the following tasks is not a suitable machine learning task? So there are 4 options. Not a suitable machine learning task. Multiple options may be correct again. Option A is finding the shortest path between a pair of nodes in a graph, predicting if a stock price will rise or fall, predicting the price of petroleum, grouping mails as spams or non-spams. So which of these 4 is or are not a suitable machine learning task? So some of you are saying option A only. One person is saying B and C. Pankaj is saying A and D. Lalit is saying B and C. So not a suitable machine learning task. You have to find out. Pranav Iyer is saying B and C. Many of you are saying A only. Devendra is saying D. Vidyadharan is saying A and C. Srinivasa Rao is saying A. Okay. Soham Chakravarti is saying A only. So the correct answer here is option A only. So A is the only correct answer here. So not a suitable machine learning test. So in case of machine learning test, you are based on some input features, you are predicting something. So for example, in option B, predicting if a stock price will rise or fall. So based on the historical data of stock price values, you are predicting whether it will rise or fall. So this is a well-known machine learning problem. Predicting the price of petroleum, this is also a machine learning problem. You are predicting the price of petroleum based on historical prices of petroleum or some other features as well. Grouping mails as spams or non-spams, so this is an unsupervised learning problem. Sorry, it is a supervised learning problem. You are predicting whether it's spam or non-spam. So this is also a very well-known machine learning problem. So these 3 options are machine learning problems. But option A, the finding the shortest path between a pair of nodes in a graph. So this is a very well-known graph theoretic problem. And there are specific algorithms present for that, Dijkstra and algorithm and Bellman-Ford's algorithm. So there are many such algorithms, but this is not suitable for machine learning tasks, that finding the shortest path. There are much easier deterministic algorithms that are already present for that. So option A is not a suitable machine learning task. This is a graph theoretic problem, and other options are all machine learning tasks. So option A is the only correct answer here. Now I can move on to question 5. This is question 5. So what is the use of validation data in machine learning? So if you have already gone through the lectures and you already know about it, that there are we divide the data set generally into 3 different parts: training, validation and testing data. So what is the purpose of this validation data set? Option A is to train the machine learning model. Option B is to evaluate the performance of the machine learning model. Option C is to tune the hyperparameters of the machine learning model, and option D is none of the above. So generally we divide the data set into three parts: training, validation and test data set. So if we divide into three parts, in that case what is the purpose of validation data set? So many of you have written B, some of you have written C also. Akanksha Yadav has written C, Srinivasa Rao has written B, Bimal Gupta is saying B. So many of you are saying B, some of you are saying C. Why validation dataset is necessary? If by testing we get accuracy is good, why then use validation dataset? Okay, I will come to that. So here the correct answer here is C. So as I've already told that generally we divide the dataset that we have into three parts: training, validation and test dataset. So the test dataset is used to evaluate the performance of the machine learning model. So this might be a little confusing, but training dataset is used for training the data, obviously, training the model obviously. Test dataset is used to evaluate the performance of the model, and validation dataset is used to tune the hyperparameters of the machine learning model. So validation dataset is not generally to evaluate the performance of the model. Validation dataset you can use to train your model further or improve your model, but you cannot use test dataset to improve your model. So there are many validation techniques are there, and you will learn about those things in later lectures. So test dataset is used to evaluate the performance. You find out the accuracy or the error, all these metrics you find out using test data, but you use the validation dataset to tune the hyperparameters and to improve the model further, but you cannot use test dataset to improve your model or fine tune your model hyperparameters further. Someone has asked, could you give examples of hyperparameters? So in a machine learning model, hyperparameters can be different machine learning models. There are different hyperparameters. Like in case of neural networks, if you have a basic idea of neural network, a neural network will contain several hidden layers, and each layer contains many hidden units. So what is the number of hidden layers that you should consider? That is a hyperparameter. How many nodes should be there in each neural network? That is another hyperparameter. And also you can treat the learning rate of the neural network training algorithm as an hyperparameter. So hyperparameters not the exact parameters of the machine learning model. In case of neural networks, the parameters are the weights or the weights of the connections between nodes, but the hyperparameters are different from the parameters. So you use the validation dataset to fine tune those hyperparameters. So for neural networks, those are the hyperparameters. For different machine learning models, machine learning algorithms, there are different hyperparameters. Based on the algorithms, it would change. So this validation dataset is different from test dataset. So you use test dataset to find out the test accuracy or generalized generalized error of your model how your model how good is your model with unseen new data. But validation data set you can use to fine tune your model further and improve it. So that is why option B is not the correct answer here. Option C is the correct answer. Option B, which is to evaluate the performance, that is why we use the test data set. Bhavik has written, so they are basically parameters of the structure of the neural network itself. Yeah, so for neural networks, those are the different hyperparameters you can think of. That what is the architecture of the neural network? That is those are the hyperparameters. So in other machine learning algorithms like support vector machines or regressions or other algorithms, there might be in naive Bayes hyperparameters should be different, completely different. So for different machine learning algorithms, the hyperparameters are different. I mean, even parameters are also different, and hyperparameters are also different. So what is the difference between validation and testing? So this is what I already told, that test data is completely unseen to should be completely unseen to the model. You cannot use the test data as part of the training process of your model. So this test data should only be used to find out the accuracy metrics of your model, how good your model is. You evaluate your performance on the test data, but validation data set you can use while training to fine tune your hyperparameters further to improve your model. So that's why option C is the correct answer. So this might be a little confusing, but C is the correct answer here. Moving on to question 6. Which of the following is an unsupervised learning task? There are 5 options. Predict the price of a house based on its area and location. Grouping related documents from an unannotated corpus. Grouping of handwritten digits from their image. Predicting the time a PhD student will take to complete his or her thesis, and option E is all of the above. So which of these following is an unsupervised learning task? So again, multiple options may be correct here. So Ganeshwar has written B and C, Shoham Chakravarti has written B, C, Raj B, C, Tejaswini has written B, C, Akanksha has written B, C. So most of you are saying B and C in the chat. Shubham Banerjee has written B. Rathajit Biswas has written B and C. Also we can group house prices based on the location and area. Okay. Shandip Bhattacharya has written B. Sunil has written B and D. Pranav Iyer has written E, all of the above. Okay. Shreya Chakravarti has written B, C. Durga Prasad has written A, B and C. Sangeeta has written E. Srinivasa has written BC, Lakshmi has written BC. Okay, so many of you are saying B and C. So B and C, these are the two correct answers here. So in unsupervised learning task, Generally the unsupervised learning tasks are grouping tasks, so you predict in which group it would be, so you cluster the given objects. You don't have the class labels present as in the case of supervised learning tasks. You have some target variable. Those are either classes or some continuous values. So for example, this price of a house, so this is a continuous target variable. So this is a supervised learning problem, so this target variable needs to be present, otherwise you will not be able to predict the price. So target variable should be there for predicting the price of a house. But grouping tasks generally do not require class labels. For example, this grouping related documents from an unannotated corpus. So you are given a set of documents, and based on some features that you extract from the documents, you will be able to group or cluster those documents where similar documents are grouped in a single cluster. Similarly, handwritten digits can also be grouped, but there are 10 digits present. So based on some features you extract from the image, you can group the digits into one of those 10 groups that you have. So that is also a clustering problem or an unsupervised learning problem. Option D is predicting the time. So time is it's a continuous variable, so that is that cannot be grouped, or you cannot use unsupervised learning for that, because you need this target variable time for that. So option D is also not correct. So option B and C, these are the two correct options here. So is there any questions or doubts? Someone asked some question regarding, Ratijit Bishwas has asked, we can group house price based on location and area, right? Yeah, we can group house prices, but we grouping you cannot specifically predict the house price by grouping. So group means there will be only specific number of groups, finite number of groups would be there, but house price it's a continuous variable, so using grouping you cannot predict the exact price of a house. So that is not an unsupervised learning problem. You can group the price range, but you cannot predict the exact price using unsupervised learning methods in option A. So now we can move on to question 7. So this is on probability. Let x and y be an uniformly distributed random variable over the interval 0, 6 and 2, 8. So x is a uniformly distributed random variable in the interval 0, 6, and y is another uniformly distributed random variable in the interval 2, 8. And x and y are independent random variables or independent events. Then you have to compute this probability of minimum of x comma y is less than 4. So you have to find out this probability value. So I will wait for a few minutes for all of you to complete the calculation. Okay, I have already received some answers here. Rahul Bhattacharya has written B. Shandeep Bhattacharya has written C. Sangeeta has written B. Okay, most of you are saying option B. I haven't received any other answer in the chat. 3-4 answers I have received. Most of them are B. One has written C. Pranav Iyer is saying option C. Shunil is saying option B. Pranav Iyer saying B. Okay, so in this question, so you have to find out probability of minimum of x comma y less than 4. So minimum of x comma y less than 4, so we can this event minimum of x comma y less than 4 can be decomposed into two events: probability of x less than 4 union probability of the x less than 4 and y less than 4. So if either one of the these two variables is less than 4, then the mean of x and y is less than 4. If x is less than 4, then mean of x y is less than 4, or if y is less than 4, then mean of x or x and y is less than 4. So that's why we can use this union symbol between these two events. So either x is less than 4 or y is less than 4, then we will have mean of x y less than 4. So they are the two events, and we have to find out the probability of the union of those two events. So we already know the union of two events, probability of union of two events. So probability of x less than 4, probability of y less than 4 minus probability of x less than 4 intersection y less than 4. So this is how we can represent this probability value. So as we already know that probability of A union B is probability of A plus probability of B minus probability of AB. So first we have to find out probability of x less than 4. So probability of x less than 4, so x is between 0 to 6, is a uniformly distributed random variable between 0 to 6, and so probability that it is less than 4. So this length is 4 and this whole length is 6, so this probability is 4 by 6. So this probability is 4 by 6. Similarly for probability of y less than 4, so in case of y, so y is between 0 to 8, and y is less than 4, so this length is 2 and this whole length is 6, so 2 by 6 minus, now this probability, these two events x less than 4 and y less than 4, these two events are independent events because x and y are independent. So these two probabilities, I mean these are independent events, so we can separate these two out: probability of x less than 4 into probability of y less than 4. So we have already computed these two values. This is 4 by 6 and this is 2 by 6. So we just plug these values in. So 4 by 6 plus 2 by 6 minus 4 by 6 into 2 by 6. So if we compute this, it would be 1 minus 8 by 36 So it's 2 by 9, so 1 minus 2 by 9, so it would be 7 by 9. So correct answer would be 7 by 9. So this is how you have to calculate this probability. So the mean of x and y less than 4, so you can decompose this event or random variable into two events, x less than 4 and y less than 4, and then you can use the formula for the probability of union of two events. Someone has written on mean we use union. Yeah, so in this case mean of two variables less than 4 is same as either of these two variables less than 4. If x is less than 4, then certainly the mean has to be less than 4, isn't it? And even if y is less than 4, in that case also mean of x and y has to be less than 4. So in this case we can use, we cannot use for every case. Like if question was mean of xy greater than 4, in that case we cannot use this union of those two events, but in case of mean and less than, we can use this union. Could you please explain the intersection part? So intersection of, so probability of this part, so probability of x less than 4 intersection y less than 4. So the there are two events, x less than 4 and y less than 4. So x less than 4 and y less than 4, these two events are independent events, because this thing is already given in this question that x and y are independent events or independent random variables. So if x and y are independent random variables, then we can separate out these two events, and the probability of the intersection is simply the probability of the individual the product of individual probabilities. So this is probability of x less than 4 into probability of y less than 4. So we can replace this intersection by simple multiplication of the two probabilities, and then probability of x less than 4 and probability of y less than 4 we can find out from the uniform distribution. So the from this we can find out these two values. If it is given maximum of the value, then what should we do? A similar question is given in the assignment, I think, so I cannot discuss the assignment questions right now. The due date is not over for the assignment. So for max, if max is given, you have to do it yourself. I can discuss that after the due date is over for that assignment, but before the due date I cannot answer that question. So Om Chakravarti has written, if max, then only intersection part needs to be solved. I didn't understand your statement here. So can you please elaborate what are you trying to say? If max, then only intersection part needs to be solved. So if the max was there, the probability of max xy less than 4, in that case you cannot do that, because even if one of those two variables are less than 4, max of those two might not be less than 4. So this you can do this thing only, you can decompose this mean of xy less than 4 to two distinct events, x less than 4 and y less than 4, because you have mean and less than. So that's why you can do. It's very basic knowledge. If either of x and y is less than 4, certainly mean has to be less than 4. Whether the other variable is less than 4 or greater than 4, that doesn't matter. Mean would be, one variable is less than 4, that means mean is less than, obviously less than 4. But max cannot be less than 4. So if max is there, you cannot do that. If max and less than is there, you cannot do that. So there is one question in the assignment for week 1, a similar question but not the same. So you have to do that question on your own. Yeah, is there any other doubt in this question? Akanksha Yadav has written how we get probability of x less than 4 equals 4 by 6. Shouldn't it be 4 by 6? No, so this is uniformly distributed continuous variables. These are continuous variables. So 0 to 6, so the length of this interval is 6, and what is the probability that the x is less than 4? So this length is 4 and the whole the length of the whole interval is 6. It's not that we are finding out that x is a continuous uniform variable, sorry, continuous variable which is uniformly distributed. So this is not a discrete variable that we will have 7 possible values of x can have any value between 0 to 6. It is a continuous variable uniformly distributed between 0 to 6. So that's why the length of possible values is 4 and total possible values is 6. Length of the region for x less than 4 is 4 and the total length of the interval is 6, so that's why 4 by 6. Similarly for y, the value y is distributed between 2 and 8, and what is the probability that y is less than 4? So so in that case this is 4, so this length of this interval is 2 and length of this whole interval is 6, so that's why 2 by 6. So Shanti, what is written? Please repeat why it is 6 not 7. So this is x is a continuous variable uniformly distributed between 0 and 6. X is a continuous random variable. So 0 to 6, so this length is 6 and we are trying to find out what is the probability that it is between 0 and 4. Hello, am I audible? I lost my internet connection for a while. Am I audible now? Okay, I was disconnected for a minute. I hope the screen is also visible. Is there any other doubt in this probability question? Okay, so we can move on to question 8. Which of the following is an unsupervised learning task? Multiple options may be correct. There are 4 options. Predict the stock market price of a company, Option B is predict rainfall for a given day. Group flowers based on similar features. And option D is predict whether an image contains a dog or a cat. So you have to find out which of these following is or are an unsupervised learning task. Some of you are saying C, some of you are saying C and D. Maybe only C because classifying is not equal to grouping. Bhavik. Rajkumar is saying C. So the correct answer here is C only. So grouping flowers based on similar features, so that is an unsupervised learning task. Obviously you are grouping flowers, not predicting specific classes. So in unsupervised learning task you are not given the classes or any target variable that you will predict. You will group objects, similar objects to same class based on some given features. On the other hand, A, B and D, all these options are supervised learning tasks, because you are predicting stock market price. You have to know the target variable values in the training data, so you need the continuous target variable, in this case stock market price. That target variable you would need. Option B is predicting rainfall, so rainfall you need the rainfall values, so that is the target variable in this case. And then option D is predict whether an image contains a dog or a cat. So this is also like 1 or 0 question, either a dog or a cat. So that is also a supervised learning task, and you need the class levels, whether dog or cat. So these are the two classes, and you need these two that target variable or the class levels to train your machine learning algorithm. So this is also supervised learning. So C is the only option which is unsupervised learning. So now we can move on to question 9. Which of the following is a reinforcement learning task? Multiple options may be correct. So you have to find out which of the following is a reinforcement learning task. Multiple options may be correct again. There are 4 options: learning to swim, learning to predict weather, learning to play video game, learning to group similar flowers based on features. So I have already received many answers. All of you are saying A and C. Okay, so all of you I received one answer, A, B, C, D. Vidyadharan is saying A, B, C, D. That is, all 4 are reinforcement learning tasks. Okay. So the correct answers are A and C. So most of you have written the correct answer in the chat. So why A and C are the correct answers? So any task that we learn or the agent learns by trial and error, and also interacting with the environment, that is an unsupervised as a reinforcement learning task. So in case of swimming, we interact with the environment. In that case, environment is the water body. So we interact with the environment, and using trial and error we learn, and the environment provides us some reward signals based on how good we are doing. So similarly, playing a video game, so learning to play video game is also something where you interact with the video game environment, and the environment provides you reward signals, either positive or negative reward, based on how you are doing or the agent is doing. And again, you use trial and error to learn that video game. So that is also a reinforcement learning task. But option B, predicting the weather, this is a supervised learning task. You are either predicting the rainfall or predicting the temperature. So you need the class levels, and you train the machine learning model with the class levels and then predict. You are not using any trial and error or interacting with the environment and the agent gets some reward signals. These sort of things are not happening here. So B is supervised learning, and similarly D is also not reinforcement learning. This is unsupervised because you are grouping flowers based on similar features. This option was also there in the previous question. So grouping is a unsupervised learning task, certainly not a reinforcement learning task. So D is also not the correct answer. So A and C, these are the two correct answers. Now question 10, this is on probability. So bag contains 2 red, 3 green and 2 blue balls. 2 balls are drawn at random. What is the probability that none of the balls drawn is green? So 2 balls are drawn at random, and what is the probability none of the balls drawn is green? You can write your answers in the chat. I have already received many answers, sir. Most of the answers are D. Shoham Chakravarti is saying C. Indumati Nagaraj is saying C. Bhavik is saying C. 2/7. Option C. Jayant is saying option C. Anamika Das is saying option C. Apeksha is saying C. Durga Prasad is saying D. So most of you are saying C, but some of you are also saying D. So the correct answer here is C, 2/7. So how can we calculate that? So the bag contains 2 red balls, 3 green balls, 2 blue balls. So there are total 7 balls are there, and 2 balls are drawn at random. First we have to find out the number of ways we can draw 2 balls from the 7 balls. That would be our sample space. So 7 balls are there and we are drawing 2 balls. So 7C2 is the sample space. This is the total number of ways we can draw any 2 balls from these 7 balls. Now we have to find out the number of ways we can draw 2 balls, 2 non-green balls. So how many non-green balls are there? 2 red and 2 blue. So 4 balls are non-green. So I have to draw from those 4 balls only. So 4C2. From 4 non-green balls we are picking 2 balls. So 4C2 is the is the number of ways we can pick two non-green balls. So this is what we want to do, picking two non-green balls, and this 7C2 is our sample space. So probability would be 4C2 by 7C2, and if you calculate it, it would be 2 by 7. So this way you can calculate it. First you find out the sample space, that is the number of ways any two balls can be drawn, and then you try to find out how many ways we can pick two non-green balls, because this is what we are trying to find out, probability of picking non-green balls. Both the balls should be non-green, so that is 4C2. So 4C2 divided by 7C2. Is there any questions or doubts in this? For Bhavik is saying for one non-green ball 4 by 7, for two non-green ball 4 by 7 into 3 by 7 2 by, yeah, this approach is also correct, that you are finding the probability sequentially. First you pick one non-green ball, probability is 4 by 7, and then there are 6 total balls and there are 3 non-green balls, so the next probability is 3 by 6, so 4 by 7 into 3 by 6 2 by 7. Yeah, this approach is also correct. Rachit is saying I did it in the same way. Yeah, both the approaches are right. What Bhavik has said, that is also fine, and this is also one way of doing that. Bhavya is saying once repeat. Okay, so there are total 7 balls, 2 red, 3 green, 2 blue, so 7 balls. So first find out how many ways we can pick any 2 balls. That will be our sample space, that is the denominator of the probability. So it is 7C2, and then find out the number of ways we can pick 2 non-green balls. We have to find out what is the probability of none of the balls is green, so we have to pick 2 non-green balls, so that probability is 4C2, because there are 4 non-green balls, 2 red and 2 blue, and we have to pick 2 from them. 4 options are there, we have to pick 2, so 4C2 is the number of ways we can do that. So our probability would be 4C2 by 7C2, and that would be 2 by 7. If the balls are placed back, how to say, if this is without replacement, and if the balls are replaced back after picking, in that case in that case the probability of picking the first non-green is 4 by 7, and probability of picking the second non-green is again 4 by 7, because you pick the first ball and you put it back, so with replacement. So in that case it will be 4 by 7 into 4 by 7. So in that case this approach is would be not correct. What Bhavik has done, using that approach, sequential approach, first you pick one and then you pick 2, so you multiply those 2 probabilities. So if the balls are replaced back, then in that case if the balls are put back, in that case it will be 4 by 7 into 4 by 7, because probability of picking the first non-green ball is 4 by 7, and probability of picking the second non-green ball is also 4 by 7, so 4 by 7 into 4 by 7 in that case. We can go to question 11 now. Which of the following are false about bias and variance of overfitted and underfitted models? Multiple options again may be correct. So false about bias and variance. So which of these options are false, not correct? False. Underfitted models have high bias, underfitted models have low bias, overfitted models have low bias, overfitted models have high variance. So DC Nayak is saying B and C, Raj is saying AD, Arvind is saying AD. Which of these are false? You have to be aware of that, which of these options are false or not correct about bias and variance. Som Chakravarti is saying BC, Rahul Bhattacharya is saying AC, Raj is saying BC, Rachit Vishwas is saying BC, Rahul is saying BD, Vidyasan is saying BD. So many of you are saying BC, many of you are saying BD. So in case of underfitting, the model would have high bias and low variance. So this thing you need to remember. For underfitting, high bias and low variance, and for overfitting, low bias and high variance. So if a model is underfitted, so it would have high bias error but low variance error. But if the model is overfitted, so it would have lower prediction error, so lower bias, but it would be very sensitive to noise and error, so it would have high variance. So based on the definitions of underfitting and overfitting, so option B is false, option C is also false. So you have to find out the false options. So B and C are the correct answers here. So B and C, these are the correct options. B and C are not correct. Underfitted models should have high bias, but option B says have low bias, so option B is not correct. Similarly, overfitted models have high bias, but option C says low bias, so C is also not correct. So B and C are the two correct options. Is there any doubt in this question? So if there are no doubts in this question, we can move on to question 12. So this is on matrix. So let the trace and determinant of a matrix A, there are 4 elements in the matrix, it's a 2 cross 2 matrix. Elements are ABCD values are not known. So trace is 6 and determinant is 16 for the matrix A, and you have to find out the eigen values of the matrix A, and there are many options. So what are the eigen values of matrix A? Bhabhi is saying, shouldn't low bias mean low bias? So bias and variance are bias and variance act opposite to each other. So when we in a model, in case of underfitting, we have high bias, that's why we have low variance, and similarly in case of overfitting, we have low bias, that's why we have high variance. So bias and variance act almost oppositely in most of the cases. Durga Prasad is saying if, and Sandeepa Vishwas is saying if. Okay. Any other answers? Vidya is saying option E. Rothit is saying option F. Amruta is saying option E. So some of you are saying E, some of you are saying F. So for this question, first we need to know the relation between the trace of a matrix and its eigenvalues, and also you need to know the relation between the determinant of the matrix and the eigenvalues of the matrix. So if x1 and x2, these are the two eigenvalues of A, so trace is the sum of the eigenvalues, which is the 6 is the trace, and determinant is same as the product of the eigenvalues, which is 16. Here it's given. So now we have to solve you have to first present it as a quadratic equation. X2 is 6 minus x1, so we can put this x2 value here. So x1 into 6 minus x2 equals 16. So it would be x1, so it would be x1 square minus 6x plus 16 equals 0. So this is the quadratic equation that we have to solve. So x1 equals minus b plus minus root over b square minus 4ac divided by 2a. So 6 plus minus so 36 minus 64, which is 28 divided by 2. So this would be it would be minus 28. So it would be 3 plus minus I root 7. So 3 plus I root 7, 3 minus I root 7. These are the two roots of this quadratic equation, and these are the two eigenvalues. So option E, 3 plus I root 7, 3 minus I root 7. So option E is the correct answer. Many of us have written F, and some of you have also written A. So this is how you have to do it. First you represent the trace as the sum of the eigenvalues and represent the determinant as the product of the eigenvalues, and then you have to formulate the quadratic equation and solve the quadratic equations. This is what you have to do. So option E is the correct answer. Question 13. An aeroplane knows that 5% of the people making reservations on a certain flight will not show up during the flight. Consequently, their policy is to sell 52 tickets for a flight that can hold 50 passengers. So there are 50 seats in the flight, but they would sell 52 tickets before the flight. So what is the probability that there will be a seat available for every passenger who shows up? So because they are selling 52 tickets, so this might happen that 51 people showed up or 52 people showed up, but there are only 50 seats. So in that case, 1 or 2 passengers would not get any seat. So what is the probability that would not happen, that all the passengers who show up would get seats? And it is known that 5% of the people making reservations on a certain flight will not show up. That is why the policy is to sell 52 tickets for a 50-seat flight. So you have to calculate this probability. So I will wait for your answer in the chat. Vipin Pandey is saying option D. Option D.
Option B.
Option B. Okay. Akanksha Yadav is saying option D. So the method to solve this problem is so you have to find out the probability that every person that shows up will get a seat. So that means so we consider this random variable x, which represents the number of passengers showing up. So this x represents the number of passengers that show up. So in that case we have to basically find out this probability, that probability of x is less than equals 50. This is the probability that we have to find out. If x is less than equals 50, in that case everyone who shows up will get a seat, and we can represent this probability as probability of x, probability of this, isn't it? This is simply 1 minus probability of x equals 51 plus probability of x equals 52. Simply this is the complement of this probability. So 1 minus of this probability is this. So what is the probability that x is less than equals 50 is 1 minus of 51 passengers showing up and 52 passengers showing up. So basically you have to find out this probability and this probability, that probability of x equals 51, probability of x equals 52. So we have to find out probability of x equals 51. So we know this 5%. So this is the basically a binomial distribution. Out of the 52 tickets bought, 51 passengers are showing up. What is the probability? So out of 52, 51 persons are showing up. So 52 C 51 and 50. What is the probability of showing up? So 5% is the probability of absence. So probability of showing up is 0.95. So with 0.95 probability, 51 persons are showing up, and with 0.05 probability, one person is not showing up.
0.069.
Vipin, are you saying something?
Sir, 0.95 की पावर 52 यानी 0.069.
Yes. So are you able to understand this part?
Yes, sir.
Similarly, probability of x equals 52 would also be calculated. So there would be 52, say 52, which is simply 1, and 0.95 to the power 52.
Yes, sir.
Sir, how it is 52C51?
So 52 tickets have been bought. So out of those 52, 51 persons are showing up. So how many ways we can pick 51 persons from the 52 that have bought the tickets? So 52 C 51 and
That is that value will be more than 1.
no, I mean, how can the value this 0.95 to the power 51 and 0.05, these things are also getting multiplied. This is simply binomial distribution. If you go back and check how can what is the formula for the binomial distribution, you will find out this thing, that out of n tickets, in this case 52 tickets, 51 persons are showing up. So what is the probability of that? We know that for every person the probability of showing up is 0.95 and probability of not showing is 0.05. So if you multiply these things, it would always be lesser than 1.
0.19.
So if you have to add these two probabilities, probability of x equals 51 and 52, and subtract it from 1. So this is the formula you have to use, and if you compute this, option D would be the correct answer.
Yes, sir.
So option D 0.74 is the correct answer. So we are using binomial distribution here. So if you are not
करना थोड़ा बैक करना सर.
what?
बैक करना से थोड़ा स्लाइड.
Yes.
ओके सर, एक मिनट रुकिए, स्क्रीनशॉट ले लेते हैं. ओके सर.
Sir,
Yes.
shouldn't it be 51C52?
50.
51C 52 because we are choosing 51 people out of 52.
51C 52 doesn't mean anything. I mean, you cannot have this upper value more than this lower value in a combination. It should be 50 out of 52 tickets, but 51 persons are showing up. How many ways this can happen? 52C 51, isn't it? Out of the 52 persons that have bought the tickets, you are choosing 51 persons. So that's why 52C 51. Is this okay?
Yes, sir.
So option D is the correct answer. Now question 14. This is the last question of the session. What happens when your model complexity increases? Multiple options may be correct. So your model complexity increases, and what happens to the model bias and model variance? So there are four options. Model bias decreases, model bias increases, variance of the model decreases, variance of the model increases. Rajkumar is saying for 0.05 because 5%. Yeah, so is the 5% people do not show up. So for every person, the probability of not showing up is 0.05, and similarly the probability of showing up is 0.95, which is 1 minus 0.05. That's why it's 0.95. So there are the four options. So you have to find out what happens to bias and variance in case the model complexity increases. So many of you are saying A and D. Rahul is saying C and A. Chindam Rakesh is saying A. Aravind is saying B and C. Babik is saying A and D. So the correct answers are A and D. So if the model complexity increases, so model bias is basically the difference between the predicted value of your model and the actual value. So in this case, it would the model bias would obviously decrease. You are increase the model complexity, and if the model complexity increases, variance would decrease. Variance is basically your model's ability, your model's sensitivity towards noise and outlier points. And if model complexity increases, the variance increases, because if model complexity increases, the model becomes much more prone to overfitting. So in case of overfitting, model increases, model bias decreases and variance increases. So the same phenomenon would happen here also. So option A and D, these are the two correct answers here. So these were the questions that I wanted to discuss in this live session. Shoham Chakravarti is asking, model complexity similar to overfitting the model. Yeah, I mean, if model complexity increases, it has same effects as similar effects as overfitting. So in case of overfitting, bias is low and variance is high. Similarly, if model complexity increases, bias is decreasing and variance is increasing. So if there are any other questions or doubts, you can ask me now. Thank you everyone.
Thank you, sir. See you.
Shoham Chakravarti is in, how can we check bias and variance? So bias and variance have some closed form formulas. You can I mean, in the video lectures also these are given, so you can check out those formulas. Those formulas can be used on the predictions of your machine learning model, and you can find out what is the bias and variance. Ideally we want to minimize both the bias and variance values, but it is not always possible. So there is a trade-off between bias and variance values. So once you try to minimize the bias, variance might increase. So you have to make a balance between these two things.
और जब पीछे जा रहे हैं ऐसे बाहर के लाम ये देख टेक्नोलॉजी को रास्ता ना है ऐसे रूप पहले से लो हम जो बाहर के लाभ है पापा उनको तो कैसे देखो करके ये नहीं जाए नहीं जाए आई नो
When you see the recording, so this recording of this session will be uploaded to YouTube, and the links will be shared by NPTEL with all of you. It has not been shared, I think, but it will be shared, and all of you will be able to access the recordings of these sessions. So I will conduct such live sessions for this NPTEL course Introduction to Machine Learning every Tuesday from 6 p.m. to 8 p.m. So we will again have this session next week on Tuesday. If there are no other questions or doubts, then we can end this session here. Thank you everyone. Thank you everyone for joining this meeting. So we will meet again next week. Pankaj is asking her session with same question. So there are 4 parallel sessions running every week by 4 different TAs. So some questions might be same, some questions might be different, and you can join as many sessions as you want. It's up to you and based on your schedule. So if you want to join all 4 sessions, you can. If you want to join only one session based on your convenience, you can do that.
So where the PPTs are shared?
PPTs will not be shared directly, but the recordings of these sessions would be shared with all of you. So from the recordings you can obviously see the PPTs.
Thank you, sir.
Rahul is asking, could you please explain what is meant by hyperparameters? So as I think no machine learning algorithm has been taught in the first week yet, so that's why it's difficult for me to explain what are the hyperparameters. So hyperparameters are basically, as I explained in case of neural networks, the hyperparameters are the number of hidden layers and the number of nodes in every hidden layer. That is for neural networks. And for other machine learning algorithms, there are other hyperparameters based on the model. So once the algorithms are taught, then you will be able to understand what are the hyperparameters for different machine learning algorithms. Yeah, neural network has not been taught yet. That's what I am saying, that I think this is only week 1, so that's why no algorithm has been taught yet. So once some algorithms are taught, then you will be able to understand what are different hyperparameters for different models. Shunil is saying, once show last slide. Yeah, this is the last slide. If you have any questions, you can ask. Recordings, so I will upload these recordings in YouTube later on, and NPTEL will share the links of these YouTube videos with all of you. So NPTEL has not shared the links yet, but they would share in near future. Bobby is saying 12th question. Yeah, this is the 12th question. So if there are no other questions or doubts, then we can end this live session now. Thank you everyone for joining.